Hi guys, warm welcome on German's MATLAB coding. In this clip, we are going to address how one can graph the S-plane plot or pole zero map of a control system. Viewers need the background of clips 36 and 37. Clip 36 addresses how one can enter transfer function of a control system from polynomial coefficients, and clip 37 addresses how one can enter transfer function of a control system from zero pole gain information. Viewer, in order to view the spline plot, we need embedded function pgmap. Pgmap has the syntax pgmap of transfer function, where transfer function is entered by earlier mentioned code. Here we go for example 1. Suppose the z of s equals s plus 4 divided by s square plus 4s plus 3. We would like to see the s-plane plot or pole zero plot for this transfer function. Obviously, the poles are -1, -3, and 0 is -4. So define the transfer function from numerator and denominator polynomial coefficients, which are 1, 4 and 1, 4, 3 respectively. Enter the two coefficients using TF and assign it to our source variable z. And in the next command line, call the pgmap where the input argument is z. Your successful execution should show you the return as you see on the screen. Poles are indicated by cross mark and zeros are indicated by dot mark. We have shown poles and zeros using encircled lines on the displayed graph. In example 2, we have g of s equals s cube plus 4 divided by s to the power 7 plus 8s plus 3. Here, the numerator degree is 3, so expect 3 zeros, and the denominator degree is 7, so expect 7 poles. The numerator code is 1004, the polynomial coefficients, and the denominator polynomial coefficients are 1, 5 knots, 8, 3. So go to MATLAB command prompt, enter the two coefficients using TF and assign it to workspace Z. In the next command line, call pgmap as shown on the screen. On the screen, you see the MATLAB response. In the slide, there are 7 cross marks, meaning 7 poles. And there are 3 circles with dots, meaning 3 zeros. This is what we expected. Now we would like to point out some textbook contexts. The horizontal and real axis in previous graph basically sigma, and the vertical or imaginary axis basically omega. These two symbols often found in control system textbooks. If the viewer would like to add spline grid, that can happen by embedded function sgrid. So go to MATLAB prompt, enter sgrid, press enter. You're gonna see the graph as shown on the screen. In here, you see there are two grid lines, dotted grid lines, straight line and circular line. The circular line basically indicates omega constant line or constancy in omega here in these lines, and the line emanating from origin basically constant damping ratio line. That's it for this coding episode. Thanks for sticking around. Inspire us by sharing, liking and subscribing our contents. I hope to see you in next clip. Bye for today.